Starship Flight 9 is right around the corner, and this one might just be the most important launch SpaceX has ever attempted. All eyes are on Starbase, Texas, where the future of human spaceflight is being built one stainless steel rocket at a time. This is no longer just about prototypes or high-altitude hops. This is the fully integrated Starship Super Heavy system being prepared to attempt a full orbital flight and controlled re-entry. And we're not talking years or months away anymore. We're talking days. The countdown is very much underway, and behind the scenes, every system, every team, and every component is racing toward one thing: proving that Starship works as intended, not just once but reliably, repeatably, and safely. It's been a long road to get here. The first integrated launch, Flight 1, was spectacular but brief. The rocket cleared the pad, climbed through Max Q, and then lost control before staging. Flight 2 came with improvements, new valves, new stage separation mechanisms, a better flight termination system. It made it to hot staging and got much further before ending in a loss. Flight 3, also known as Flight 8, was a turning point. It demonstrated successful hot staging, achieved stage separation, relit the ship's engines in space, and initiated re-entry, though the vehicle didn't survive. But each attempt has taught SpaceX something new. Every test is a feedback loop. Failures aren't setbacks, they're data points. And now, all that data is being funneled into Flight 9. At the heart of this mission is Ship 35. This isn't just another test article. It's the first of the Block 2 design, SpaceX's next big leap in upper stage performance. Block 2 is expected to feature numerous upgrades over the earlier ships: refined structure, optimized thrust section, better avionics, and a significantly reworked heat shield. Every black tile covering Ship 35 represents an attempt to solve one of Starship's biggest challenges: surviving the fiery return through Earth's atmosphere. We've seen what happens when just a few tiles fail. Superheated plasma penetrates the vehicle's skin, and it all comes apart. But with Ship 35, SpaceX believes it has made major progress. If it works, this flight will prove that Starship can not only reach orbit but make it back in one piece. And then there's Booster 14. This isn't its first rodeo. It previously flew on Flight 7, making it one of the few super heavy boosters to be reflown. While not fully reusable yet, SpaceX is inching closer with every flight. This time, the booster is expected to separate cleanly from the upper stage, perform a controlled descent, and splash down in the Gulf of Mexico. It won't be caught by the launch tower's chopsticks, at least not yet. But the data gathered from its descent will directly inform future booster recovery attempts. It's another step toward making this entire system reusable from top to bottom. But before any of that can happen, the rocket has to get off the ground. And that process starts with the static fire tests, short but powerful bursts of engine ignition while the rocket remains bolted to the pad. Ship 35 completed a 6-engine static fire, but one of its vacuum Raptors had to be replaced. It was a quick fix. SpaceX rolled it back, swapped the engine, and sent it out again, an impressive demonstration of how rapidly they can diagnose and resolve issues now. On May 11th, a curious event unfolded. Ship 35 was back at the Massey test facility, fully fueled with cryogenic propellants. Frost lines ran high up the ship's tanks. Venting began. Then the deluge system activated, water flooding the test stand to suppress heat and noise. It looked like a static fire was imminent. But then, silence. No ignition. It might have been a spin prime, a test where engines are spun up but not fired. Or maybe something wasn't quite right. Either way, it signaled that final tests were nearing completion. Next up is stacking. If SpaceX moves Ship 35 to the orbital launch mount as expected, it will be joined with Booster 14 to form the full Starship stack, taller than the Statue of Liberty, more powerful than the Saturn V. When that happens, it's go time. The FAA has already issued a NOTAM covering a massive airspace corridor, stretching from South Texas to the Caribbean. That suggests Flight 9 could follow a longer flight path than before, possibly even attempting a more complete orbital trajectory. Meanwhile, the U.S. Coast Guard has marked off a hazard zone in the Gulf, set to be active on May 20th with backup dates through the 29th. That's the launch window. Everything's aligning. The vehicle is nearly ready. The infrastructure is in place. And the clock is ticking. But why does this flight matter so much? It's because Starship isn't just a test vehicle anymore. It's the backbone of SpaceX's future, and not just SpaceX's but NASA's too. Under the Artemis program, Starship is slated to land astronauts on the moon. Not a prototype, this very system. And that means SpaceX has to prove that Starship can not only launch, maneuver in orbit, dock, refuel, and land with precision. Each piece of that puzzle starts with test flights like this one. If Flight 9 goes well, it proves the concept. It says, yes, this thing can fly, survive re-entry and be controlled through the most difficult parts of its mission. And beyond NASA, the Department of Defense is watching closely. They've invested in Starship for rapid point-to-point cargo delivery across the globe. Imagine being able to send military aid or emergency supplies anywhere on Earth in under an hour. That's what Starship could unlock. But again, only if the system works. Only if it can be launched, landed, and reused quickly. Then there's Starlink. The current Falcon 9 system is maxed out. It can't deploy the massive, power-hungry Starlink version 2 satellites at the scale SpaceX needs. Starship changes that. With its enormous payload bay and higher lift capacity, it could deploy dozens, even hundreds of satellites at once. And that's essential for global coverage, faster internet, and long-term profitability. Starlink is not just a service, it's what's funding Starship's development. Every part of this ecosystem feeds into the next. But it all hinges on Starship working as intended. That's why this flight carries so much weight. It's more than a test. It's a statement. And here's something else to think about. What happens after Flight 9? Ship 36 and Booster 15 are already in advanced stages of preparation. We're likely to see them fly within weeks of Flight 9. SpaceX is accelerating the pace. They're building, testing, and launching faster than ever. This rapid cadence allows for fast iteration. Problems can be addressed between flights. Designs are evolving almost in real time. That's how SpaceX moves, agile, relentless, and always forward. Back at Starbase, things are buzzing. New fuel tanks are being installed to support higher propellant loads. The launch tower is being reinforced. A second tower is already under construction. The factory floor is full of new sections, domes, thrust pucks, common bulkheads. Raptor engines are rolling out from the McGregor test site at a steady clip. SpaceX is preparing for a world where Starship isn't launching once every few months, but once every few days. Elon Musk has made no secret of the goal. He wants to colonize Mars. And Starship is the only vehicle capable of making that possible. But it's not just about Mars. It's about redefining spaceflight entirely. If SpaceX succeeds, launch costs will plummet. Missions that once took billions could be done for millions. Entire new industries could emerge: space manufacturing, lunar mining, deep space exploration. But first, Starship has to prove it can fly, land, and fly again. That's what makes Flight 9 so important. It's not just the next step. It's a proof of concept for everything that comes after. If the upper stage completes its mission, reaches orbit, conducts an engine relight, begins controlled re-entry, and survives splashdown, it will be the most complete Starship flight to date. It will validate years of design and testing. And it will open the door to the next phase: catching the booster, refueling on orbit, and eventually launching crew. The world will be watching. And rightly so. Because what's happening in South Texas right now is more than just engineering. It's history being written. Just like the Apollo missions in the 1960s, just like the space shuttle in the 1980s, this is the dawn of something new. A different way of thinking about space. A future where the solar system is accessible, not just to governments but to humanity as a whole. And so we wait. The rocket is nearly ready. The permits are lining up. The teams are in position. It won't be long now before Starship Flight 9 roars to life. Whether it succeeds or fails, it will teach us something. And whatever it teaches, SpaceX will use it to build the next version. Faster, stronger, better. Because that's how you get to Mars. Not by waiting for perfection but by launching, learning, and launching again. So buckle up. The future of spaceflight is about to take another giant leap. And whether you're watching from a beach in Boca Chica or a screen on the other side of the world, you're witnessing the birth of a new era. One that could change everything.